Polarizing filters were first discovered when the toxicologist Herapith mixed iodine with the urine of a quinine-fed dog. Upon contact, he observed that the crystals sitting atop one another at right angles were black as midnight. This eventually led to the first ever polarizing filters for commercial use, which were invented by a Connecticut scientist, Edward Land, in 1929. Land wanted to develop a way to polarize light ever since he was 13, when he wondered if there was a way to reduce the bright glare from oncoming cars so as to improve nighttime driving. Over time, this led him to the development of polarized film and canvas. The way polarized filters work is that they block light flowing through in a certain angle. Once this light is twisted, for example, by a crystal display, it can then pass through another filter positioned at a different angle. This allows for better image quality while also negating reflection.
Polarizing filters function similarly to a wire grid polarizer. It's made of microscopic arapathite crystals, also known as iodoquinine sulfate. The crystals are dichroic, which allows it to polarize light. Its current H-sheet form is made from polyvinyl alcohol plastic with an iodine doping.
Polarizing filters have many practical uses in the real world. Sunglasses and windshields use them to reduce glare and to make images more clear and less bright. LCD or liquid crystal display screens use polarizing filters to allow the light to come through when it receives the image. Film photography, such as Polaroid cameras, use multiple layers of polarizing filters that allow only certain colors to go through, which allows the picture to be printed instantly. And 3D glasses, such as the one on the screen, are used in many movie theaters to create a 3D image from multiple 2D images overlaid on top of each other. Here is an image taken on an electron microscope of a polarizing filter. In the first two images, it shows one polarizing filter in one orientation. However, in the third image, it shows two polarizing filters at exactly 90 degrees apart from each other. It shows how a significant amount of light is blocked when the two filters are crossed at 90 degrees.
Iodine is found in the thyroid gland. It is also used as a surgical disinfectant and as a food additive. Iodine was discovered in 1811 by Bernard Courtois when he added sulfuric acid to saltpeter, which created purple flames of gaseous iodine. Iodine is mainly found today in seawater as iodide or in brine deposits where it's mined. Many methods of extraction for iodine exist, one of which being the blowout process, in which oxidized iodine is mixed with sulfur oxide, which reduces into an acidic iodide solution. The solution then solidifies into iodine crystals after adding chlorine, which are then harvested. Iodine, besides its uses above, can also be used in the treatment of radiation exposure in the compound potassium iodide, and it is also used as a contrast dye in X-rays when used as an IV injection. The major use of iodine today is as a food additive, in which it prevents the formation of goiters in the body due to a thyroid deficiency. As a result, it is a major import for many countries and serves as a steady market in the global trade.